Welcome to the CanMed Coffee Talk podcast, where we talk with the leading minds in cannabis science, medicine, cultivation, and safety testing. I am your host, Ben Amaralt. I'm the marketing manager at Medicinal Genomics and proud member of the team that puts on the CanMed conference. Okay, we are back to our normal podcast format this episode, but I hope you enjoyed the conversations we recorded live at CanMed 2022 in the CanMed Coffee Talk Lounge. It was great to have some face-to-face interactions with folks, and I look forward to doing it again real soon. Speaking of doing it again, we are working hard behind the scenes to get all of our ducks in a row so that we can announce details around CanMed 23. While I'm not allowed to give too much away, I will say that next year's event is going to be unlike any other event we have done so far. You aren't going to want to miss it, and I can't wait to share the details. Of course, you can tune into the podcast for updates, but you can also sign up for email alerts at canmedevents.com and follow us on social media to make sure you are among the first to receive the announcement. This episode features a conversation with TJ Martin, who is the VP of R&D at Abstrax, a company that specializes in research, development, and production of botanically derived and cannabis-inspired terpenes. TJ and his team recently published a paper that identified a new class of aromatic cannabis compounds called volatile sulfur compounds, or VSCs, which are responsible for that signature skunky, gassy smell that is so prominent in certain cannabis cultivars. This was a major breakthrough for their team because, as TJ mentions in the conversation, a common criticism of botanical terpenes is that they can't recreate the signature gas smell of an OG or a gelato. It was a critique that inspired TJ and his team to investigate what they were missing, and lo and behold, they found VSCs. During our conversation, we discuss Abstrax's process for recreating flavor profiles for classic cannabis strains, how TJ and the team used multi-dimensional gas chromatography to separate compounds by molecular size and polarity, revealing additional compounds, how even though VSC concentrations are orders of magnitude lower than terpenes, their effect on our taste and smell is much higher, the similarities in structure between cannabis VSCs and VSCs found in garlic, and what medicinal implications that discovery may have. And finally, although VSCs are needed to create that skunky, gassy aroma, it is actually a combination of VSCs and other terpenes that makes that signature smell. Before we get to my conversation with TJ, I want to thank this episode's sponsor, Advanced Nutrients. Founded in 1999, Advanced Nutrients was the first to develop a complete nutrient system that unlocks the true genetic potential of the cannabis plant. Since its inception, the brand has introduced more than 50 innovations to the cultivation community and continues to revolutionize the space through proprietary scientific discoveries. Learn more at advancednutrients.com. All right, and without any further ado, please enjoy my conversation with TJ Martin. Good afternoon, TJ. Thanks for joining us on the podcast.
Thanks for having me, Ben. Really stoked to be part of the podcast.
Yeah, me too, because today we're talking all about that stinky, skunky smell that's so potent in certain strains of cannabis. And, for a long time, that skunk smell or that gas was one of the few things cannabis users could use to judge the quality of cannabis. Of course, today we know that good cannabis can smell like just about anything from fruit to herbs. And so, TJ, I was hoping you could start and tell us a bit about what interested you about researching the causes of that skunk smell in cannabis.
So what really interested us over here at Abstrax, we're a company here who we're a company that focuses on cannabis flavors and aromas, not only just botanically derived, but also cannabis derived. So we have one business that's Abstrax Tech. So we do all of our non-cannabis infused flavors. So these are directly replicating the exact flavor and aroma of cannabis. but without using any actual cannabis in it. So if you're a brand who wants to be like Coca-Cola and have your product in every single state and country in the world, but have it taste exactly the same, like you want, so you own Jack Hare or Gelato or Runts or Cushman's, right? And you want it to taste the exact same in every state. Well, you can't extract it and ship it to every state. That'd be illegal. But we can create it in a botanical format using our research to directly replicate that exact smell and aroma. And then now, since it has no cannabis in it, we can ship it to every state and country in the world. So as a brand now, you can start building that brand recognition and that flavor profile that people know and love in every single state without any concerns of variability or legality. And we also have our cannabis touching business, which is our licensed extraction facility and research facility in Long Beach, where we research and understand what makes each cannabis strain different and unique. Why does Jack Hare have its own unique scent that's wildly different from Gelato, which is also wildly different from like OG Kush? I mean, yeah, some of these, two of those have really heavy, gassy, skunky scents to them, right? But Gelato and OG Kush are wildly different, not only from when you smoke them and consume them, but also to just how they taste. Gelato is known to have a really complex layered flavor profile, hints of berry, citrus, earthy, musk, as well as a ton of gas in it, right? Whereas OG is very woody, piney with a lot, maybe some citrus notes, depending on which OG you like, and a lot of gas on it as well. And so at that facility, not only do we create cannabis flavoring extract products, we also research and understand what makes those things tick, right? Why they're all unique and different.
Great. So maybe a good place to, well, first of all, I'm glad that you're an expert on the aromas of cannabis because I'm curious. So I was wondering, can you explain the different types of compounds that contribute to the aromas of cannabis? Because I think, we like to think most people are at least familiar with terpenes. And that's what a lot of us associate with the aromas. But are all, the scents associated with cannabis necessarily terpenes, or are there different classes of those compounds?
So, I mean, cannabis produces a wide variety of flavor compounds. You'll see everything from terpenes, sesquiterpenes, terpenoids, right? As well as other flavor compounds. These may be esters, ketones, aldehydes, alcohols, volatile sulfur compounds like the sulfur compounds we discovered in our paper.
Mm.
It's a whole wide variety of different flavoring isolates and found in cannabis. And even if you break down terpenes into things like terpenoids, you can start seeing other of these like alcohols within terpenes. So like a terpene alcohol like menthol or linalool. These are known for minty and more lavendery floral scents, as well as aldehydes like citronellal or ketones like camphor. Um, these are just typical flavor isolate. These are just different ways of how the chemicals orient in space, like they have oxygen in them, which then gives them more either potentially pungent or different flavor notes. And your volatile sulfur compounds always have sulfur in them, and those typically tend to be by far the most pungent, right? I mean, you can smell, when you're driving by a weed grow by the skunky smell, not by, the minty smell.
Right. Yeah. So, in reading through your paper, you determined that the compounds that create the skunky smell are these volatile sulfur compounds, like you mentioned. So, how did you determine that it was this new family of volatile sulfur compounds that were creating the smell and not more of the well-known like isoprene derived compounds?
Well, we didn't know going into it, right? We went into the project knowing cannabis gas is something that, as an industry, we don't know definitively what it is. We know skunky, gassy smells obviously exist. We can smell it in the plant, but at the time, there was really no terpene products out there that directly recreated this. There was no products really on the market that did. And so into the project was, well, we know there's some strains that have less gas than others, or no gas, like a Jack Hare. And there's some that have a ton of it, like Gelato and OG Kush. And so we just started procuring a lot of fresh, really high-end genetics. Because of our extraction facilities licensed, we have the ability to procure from anybody within the California marketplace, and just started pulling in lots of different samples and analyzing them and looking for trends to see if this strain smells gassier than another. Well, what are the differences here? Where is this trend going? That's what you'll see in the paper. We've kind of oriented these from highest gas to something like Baccio Gelato. which anybody who's consumed Baccio Gelato from Stravinsky's, extremely gassy, right?
Hmm.
By far some of the most pungent weed you can find on the market. All the way down to something that doesn't really have any skunky smell to it. It's really good, but doesn't have skunky notes to it, like Jack Herer. That's not really what it's known for. And then everything else in between.
So yeah, so tell me a bit more about how you went about designing the experiment to identify these compounds. Like, what was novel about your approach, and why hadn't anyone kind of found these compounds before?
So your typical testing labs and a lot of cannabis companies are going to have something like a one-dimensional gas chromatograph with a mass spectrometer on it. That
Hmm.
is, I don't know how familiar you are with it, but GC basically separates based on molecular size in a 1D
Right.
system, and a mass spec allows you to see what those compounds are, right? But it's very limiting. It's good for what it does. It's high throughput. It's affordable, but it does have its limitations because you're only going to see anywhere from 20 something to maybe cap out at 80 to 100, depending on how deep you go into your method development, right? Whereas what we have is a custom built out multi-dimensional gas chromatograph, which allows us to not only separate based on molecular size, but also polarity. So
Hmm.
some of these volatile sulfur compounds, these oxygenated species that may come out at the same time as a terpene, are now able to separate out in the second dimension. And we get way
I see.
better chemical characterization. And we also have a mass spectrometer on there and also a sulfur chemiluminescence detector, which allows us to see all those specific sulfur compounds only on the detector. So kind of helps guide our research. Really fancy, expensive equipment, right? It's very specialized. It does take a specific science team to actually run it. It's not as easy as a 1D by any sense. And you do not get it, it's not as high a throughput. But what you lose on your throughput, you gain on the characterization abilities.
Interesting. Interesting. So adding that second dimension enabled you to get, more resolution to see, kind of maybe similar weighted compounds that are different in other ways.
Correct. Yeah, they'll be similar weighted, but because they have, say, oxygen in them or sulfur, now they're going to
Yep.
separate out from those compounds that don't have any oxygen or sulfur in them. So
Right.
now it's a
So in that one dimensional readout, it would just look like all the same thing.
correct on a 1D system. If you're
Right.
running a typical 1D system, you're going to see, obviously all your peaks, right? Well, within
Yep.
one of those peaks, say at like 5 minutes, there could be one compound, there could be 20 compounds there.
Right.
They all come out, they all loot out at the same time. You have no way of separating it into a second dimension because you're a 1D system.
Huh.
Whereas ours, we pull it into that second dimension. So now it's like you get a second layer of separation.
Right. So I'm curious. So what other terpenes kind of come up at a similar time point as these VSCs? Like, were we kind of maybe misappropriating some of the gas smell to a different terpene just because it has a similar weight?
I mean, I have to look in the data specifically to see exactly
Hmm.
what's coming out at the same time. But I mean, these VSCs are in very minor concentration. So even on a
Oh, okay.
typical 1D, like you're talking, these VSCs are low part per million, typically in part per billion range, whereas terpenes are in the percent level,
Hmm.
right? If you're talking about the relative weight to one another, like myrcene, a lot of strains like an OG is going to be like its aroma fraction 60 to 70% maybe myrcene,
Yeah.
whereas that volatile sulfur compound is just, I mean, you're sub percent, you're way down there. So on a
Wow.
typical system, even if you were looking for it, you're just not going to see it because there's such a low concentration unless you have that extra layer of separation or if you have the right detector to look for it.
Yeah, but in this case, a little goes a long way, right? Because, even if it is, orders of magnitude lower than those other terpenes, like that's usually what breaks through. That's the most pungent smell that you get.
Oh yeah, this is where, I mean, just because it has a lower weight doesn't mean its impact on your sensories are that much lower, right?
Right.
Every isolate has a different pungency to it, and sulfur compounds, as we're all aware with like skunk spray itself from like an actual the animal skunk itself, very pungent, right? Super super pungent. You can smell skunk from miles away at that point, right? Same thing with cannabis. These things aren't in high concentrations, but their organoleptic impact, how it impacts your how you taste and smell, very very high.
Mm.
Whereas something
And
like
now are
myrcene
they
is a lot lower.
Yeah. Now, are they more volatile than your typical terpenes too? Like, do they, sort of burn out fast?
Some of them, yeah, like parental mercaptan, one of the main thiols we detected in cannabis, super volatile,
Hmm.
really really volatile. I mean, It's definitely more volatile than like beta-caryophyllene and the sesquiterpenes, right? Those aren't, I mean, those are volatile, but they're not as volatile. And I haven't really done extensive studies to quantify it, but it's definitely, I'd say, more volatile than things like myrcene as well.
Interesting. So I know that as part of your research too, you were looking at how these levels of these VSCs change throughout the plant's life cycle. I was hoping you could talk a bit about that.
Yeah, so in the paper, we also did a greenhouse experiment where we grew out cannabis plant and monitored the VSC evolution through from when it was first growing at everything from week 1 all the way through cure when it was finished curing. And what we see is around weeks 6 and 7 is when the plant starts producing these volatile sulfur compounds, these sulfur compounds. And I mean, we were growing out, I believe it was gelato specifically in the paper. We obviously different cultivars are going to be different, right? It's just cannabis has so many different cultivars and so many different strains that it's just this wide variety of potential here. But typically, from what we saw in gelatos, right around week 6, 7 is when it starts, and then definitely right once cure is finished, that's when it's at its height. That's when there's just so much concentration of those VSCs, and it makes sense, right? Super fresh weed, as you mentioned, when you're looking for quality, specifically like on like an OG or a gelato, the fresher it is, the more gassy it is, and you know that it tastes better, has a more perceived euphoric impact, just a better overall product at that point, and it makes sense. It's fresh.
Yeah, and I know that you looked also at the storage conditions for some of these flowers that you got a hold of too. So, what is sort of the optimal storage conditions to preserve these VSCs?
So I mean, we're still looking into storage conditions, right? I don't have a ton of data on that, but I mean, if you look at it if you're comparing like a mason jar to like a sandwich baggie, two very common, typical ways people may store cannabis at home. Sandwich baggies, not exactly conducive to keeping things away from air, right?
Hmm.
It's going to off gas a lot. It's going to leave the baggie because they're not fully sealed. Whereas something like a mason jar or any kind of type of canning jar is going to have a nice tight seal on it, which explains why you're able to preserve your cannabis longer, right?
Absolutely. And what about extracts? Do the VSCs sort of go through the extract process?
Yeah, in our paper, we looked at some extracts because we have an extraction facility, right? So we did some experiments with our hydrocarbon extractors, and we saw that these sulfur compounds do go from the flower into the extracts, and that makes sense, right? If you're somebody who loves waxes, whether it be rosins or even hydrocarbon extracts, they're still gassy. They still have that gassy, skunky note to them, so you can smell it there, so you know it's there.
Absolutely, absolutely. And now, one part that kind of stuck out to me in the paper too, and you have a nice visualization of this, was the similarity between these cannabis VSCs and the VSCs that are also found in garlic. I was wondering if you could speak a bit about that, and I'll definitely include a screenshot or a picture of that visualization that you had, because it's really interesting to see just how similar these compounds are. It's just that cannabis has an extra, and I'm sorry, I'm not a chemist, so it has a few extra lines on there, and I'm sure you can explain what that is.
Yes, I mean, that was actually, we didn't, this is not something we anticipated at all, right? We really just want to see, well, what makes cannabis tick? Where does this gassy, skunky smell come from? And as we're going through the data, it was just really strange that if you look as a trend from the garlic volatile sulfur compounds and same thing the cannabis ones, you have very similar structural motifs going through them all as far as like how the sulfur is oriented in space. Um, Cannabis has that same thing, but instead of being an allele, it's a mercaptan group. So you have the extra two methyl compounds on the very end. So you have two more carbons to it. But the actual sulfur aspect of it on the end, whether it be the terminal thiol or a sulfur bonded to a methyl group, or being a disulfide or just a sulfide in the middle, it followed that same trend as what you see in garlic. And so these compounds actually in garlic, like allelephiles, what's being investigated for its anti-cancerous benefits, and some of the other thiols mentioned have been potentially attributed to the cardiovascular beneficial properties of garlic as well. So that begs the question of like, does cannabis have similar benefits? Does it have other medical benefits from these sulfur compounds that we've detected? And Are they similar? Is it more pronounced? Is it something different? Does this change how cannabis impacts you, right? Is this potentially to explain why fresher cannabis has a bigger impact on the body than, say, 6 month, a year old weed? I mean, any avid consumer will know that, can tell you from, at least from anecdotal evidence, they prefer fresher weed. That makes sense, right? We don't go to the store and buy 8-month-old oregano. You want
Right.
fresh oregano for your products. The same thing applies here, but it begs the question: how does this impact the actual experience of the product, and what medical benefits are there? It's a question we don't know the answer to yet, but would love to find out.
Yeah, we'd love to find out too. And if there's any listeners who are looking for something to investigate to maybe potentially bring to a future CanMed, this would be a great topic to take on. And this really ties back to what you were saying before too, right? Where at your business, you're looking to recreate a lot of the aromas that are associated with these signature strains, but using compounds that aren't cannabis derived. So is this a good example of where you could use some otherwise derived compounds to recreate a cannabis smell?
Yeah, so I mean, with our research over at Abstrax Labs, where we have our cannabis license and our instrumentation for analyzing we have our multidimensional GC, we're able to see everything that's in the plant, right? At least that's volatile, which attributes the majority of its flavor and aroma. And we can take that data and then recreate it using the same isolates. Like prentyl mercaptan isn't only found in cannabis; it can be found in other things. Like when you look at, say, skunky beers, like a Corona, like a light struck beer, that has prentyl mercaptan in it. And so these compounds can be found, some of them, in other botanical species. So you can extract these, isolate them out, and then use them in the same ratios and have the same compounds to directly recreate that exact same scent. Because prentyl mercaptan, if it's isolated from cannabis or isolated from, say, hops or some other botanical species, once you isolate it down in a high enough concentration, it's going to smell and taste the same. And it's just about matching those direct ratios.
Yeah, and I know as part of your paper, you were trying to reverse engineer some of the aromas of the cultivars that you were studying. Talk a bit about that. And I thought it was interesting that there seems to be an entourage effect when it comes to aromas as well.
Yeah, I mean, with that, we obviously have the data to know everything that's in there. And so we wanted to recreate it isolate by isolate and see, when does it start smelling skunky and gassy, right? It's one thing to see trends in the data. It's a whole other thing to actually experience it and confirm this is what it is. So we take the major terpenes, things like myrcene, limonene, caryophyllene, terpinolene, pionenes, right? Start adding those in the right ratios that we're seeing in, say, baccio, gelato. And just kind of going down the list and adding in other terpenes or flavor compounds we're identifying and noticing, when does it become that skunky, gassy aroma. And it's not just prentyl mercaptan by itself. Yes, prentyl mercaptan, as well as some of their cannabis-sulfur compounds, are a huge driver for it. But you also need those terpenes there. If you don't have those terpenes and terpenoids, it's not going to smell like cannabis. It's not going to smell like that signature gassy scent. It's just going to smell very sulfurous, maybe potentially a little bit catty or skunky, but it's not like the cannabis gas like you would notice in an OG or a gelato. So it's what the cannabis community loves so much, right? And so really what we were doing is just utilizing that data and just slowly going down and seeing, just trying to identify one by one what's needed. And we did this with just terpenes. We did it with just the VSCs, as well as then adding the VSCs to the terpenes to see what is that scent that we're looking for.
Yeah, and you mentioned that it is such a signature aroma and one that the community loves so much, and it has to be part of the reason why the what is the original skunk always seems to come up on social media, and it's just interesting how that skunk smell has become just so synonymous with cannabis.
It has, and it's super polarizing, right? The cannabis
Yeah,
community loves it. People who don't consume cannabis a lot of times hate it.
yeah,
Absolutely hate it. They're just really put off by it, and maybe that's why they may prefer strains if they're new consumers in the market. They're looking for something a little bit fruitier, more like Jack Herer. But regardless, I mean, not only does this research kind of elucidate potential health benefits to look into, obviously calls out exactly where these scents come from, but provides guidance for people who try and do odor mitigation or
Mm,
controlling the odor on their grows, so that way you're not upsetting the general community around you, right?
yeah,
Can't lose sight of that. I mean, yeah, our community really enjoys this scent, but a lot of the population doesn't, unfortunately. And
right.
it is a very pungent scent that does permeate everywhere it's at. I mean, drive through downtown LA, where there's a lot of cannabis grows, and you'll smell it just driving on the freeways. It's
Right.
crazy.
Yeah, and like you said earlier, I mean, that is the scent that people associate with cannabis. You know, if you smell a more fruity strain out there in the wild, you're not immediately going to think cannabis. But when you smell that gas, like there's no mistaking like what that is. And I'm
Exactly.
curious too, like with your business. I mean, your business is in recreating aroma. So was there a lot of demand for creating this scent in particular?
I mean, that's always been a critique of botanical terpenes, right? Not going to shy away from that. I mean, it's one of the critiques on social media is that botanical terpenes may capture some aromas of cannabis, do really well with like hazes and Jack Herrera type strains. But when it came to OGs, it was significantly lacking that it missed that signature gassy, skunky aroma. And scientifically, I mean, I was just interested in why, what is that? That's why we kind of pursued this project. And being able to actually recreate it in that flavor and fragrance format allows brands now to, like I said, take their product across state markets, across state lines, country lines, and have that exact flavor and aroma now because we can directly recreate it using these compounds. Don't get me wrong, it's a lot of work. It's very
Yeah.
expensive, ton of work, a lot of time to recreate that exact profile. But once you do, I mean, it's really rewarding. There's some people who we've created products. I mean, one of the stories I like to show people or tell people about is when we first started making these discoveries, when we were reverse engineering and recreating these products, we started formulating some vape pens at our lab. Um, we also did some with CBD. Started handing them out to people, and they started smoking through and tasting them compared to just regular botanical blends. And when they would smoke the ones that had all the compounds in there from all the reverse engineering work, some folks were like, "Oh, this is a really nice live resin pen." Like, well, it's not a live resin pen. That's actually
Right.
botanical terpene. We've just been able to identify and really pull in all the different flavor isolates that previously had been undiscovered in cannabis. And so when you're able to really recreate it and make the product taste like live resin, I mean, just as a scientist, it's just so cool. You know what I mean? Being able to finally figure
Yeah.
those things out.
Yeah, that's quite the vote of confidence to be or the seal of approval to get that to get that. That's great. Um, yeah, and before we started talking, you were talking about how it's great at your facility, or it's great that management of your team has this publish first sort of mentality. Because you know a lot of other folks who would have made this discovery, especially in your field, may have held back that information and not made it public. So speak a bit about why you thought it was important to share this information.
Yeah, I mean, I'm very blessed here at Abstrax. We have an ownership team that really believes in educating the cannabis community and sharing this information that's so important to the community, and a science team as well that really really buys into that as well. And so when we made these discoveries, I mean, if you're in a typical privatized industry, it's very common that most of your work doesn't get published. Maybe you get a patent here and there when it's possible, but the rest gets filed away in the basement and never to see the light of day. Whereas the approach here with Abstracts, our ownership is, hey, we have a community that really wants to see this information. We think it really benefits the community, as well as this is a plant that historically hasn't been researched very much. This could be due to, it's pretty difficult to research it in a university setting. You have to go through a lot of red tape.
Hmm.
You don't really have access to all the different cultivars that are on the market like we do. And so when we found these cool discoveries that we thought, man, the community will really love to see this, you have to publish it, right? You can't discover the gas and not tell the community about it. It would just be, I mean, such a travesty to the industry to not show this information to the whole world and educate the whole community.
Yeah.
And it was great. I mean, the community really loved it. Everybody fully bought into it. Was looking at reading the paper, really appreciated all the support, and hopefully, it just encourages more folks to publish as well. Because as a community, there's not a lot of science out there, and the universities can't touch it. I mean, yeah, they can research cannabis, but they can't research cannabis that's grown by like a Shervinsky's or Cookies or Jack Herer, any of the major brands that you're seeing in all these states. Like, these are not strains that the universities can research, but we
Right.
can as a privatized community and when we have actual licensed facilities.
Yeah, you're absolutely right. And, I think that we at Medicinal Genomics kind of share that same philosophy. And that's always been our approach is to publish and get the information out there to benefit the community. And it's part of the reason why we put together CanMed, right? Is to bring together these other people or other companies who are sort of taking up the mantle for getting research going on this plant. Because like you said, there are universities that are coming on, but they're studying hemp, which is very valuable, and a lot of it's going to apply also to cannabis. But you're right, in terms of really looking at these well-known cultivars that are purely cannabis and are not going to be mistaken for hemp. It's really up to the private companies to do the work.
Exactly. I mean, like I mentioned in the beginning of this, big fan of medicinal genomics for a while here. Love love all the work you guys are doing. I think it's great to educate and support the cannabis community. It only helps better serve our community by having people who are more educated on their products, helps them make buying decisions when they're looking for things that how is this going to impact them? What flavors are they looking for? It's no longer just, I'd love to get to a point where it's no longer just strain names, right? And marketing
Right.
around strain names, but actually, how do these things smell and taste? How do
Yeah.
these things impact you? Because there's so many cultivars out there. They're so wildly different. And there's a ton of work to be done, but that's what makes it so much fun.
Yeah. Yeah. And we need to get beyond just straight THC values too, right?
Oh, for sure. I mean, if it was just THC values, why would Jack Hair impact you differently than an OG Kush or than a Gelato or a Runts, right?
Exactly.
I mean, anybody who's an avid consumer can tell you the difference and how it impacts them, especially when it's fresh, right?
Yeah, absolutely. All right, so winding down here, TJ, before I let you go, I wanted to give you a chance to plug any social media or websites or other resources that you think that the listeners would be interested in learning more about.
Yeah. You can follow our social media at Abstrax Tech on Instagram. So we post a lot of our new product launches, where our research goes, any educational pieces or collaborative work we do, as well as our website, abstraxtech.com. It's Abstrax with an X, by the way, not a CT. And on abstraxtech.com, you can buy all of our different terpene products, whether they be typical flavor blends, because we do create traditional flavors, as well as our cannabis-inspired products. Also on there, it's where we publish all of our white papers and our different peer-reviewed publications as well. So we have some really interesting ones on there your community may enjoy. Like we did do a white paper looking at what is the difference between flower, hydrocarbon extracts, and rosin extracts of the exact same cultivar, same lot, but applied different extraction processes. And we looked at the different flavor and terpene isolates found in each and how those changed to try and the way we can. I mean, because we all know they do have different flavor profiles, and why is that? And so we went ahead and looked at it. So definitely something to check out. We do publish that on our website.
Excellent. Yeah, we will definitely be checking that out. All right. Thanks again, TJ, for joining us on the podcast. Keep up the good work, and hope to see you out at a future CanMed event up at the podium presenting some of this great work.
Thanks, Ben. Looking forward to seeing you guys as well. Thanks, man.
All right. I hope you enjoyed my conversation with TJ Martin. Check out the links in the show description to learn more about the topics we discussed. And thanks again to this episode's sponsor, Advanced Nutrients. Our next episode will drop June 22nd. That's 2 weeks from today. In the meantime, I hope you will continue to engage with us on social media. Just search for canmedevents.com across all those platforms. Continue to contribute to our CanMed community Facebook group, and also remember to sign up for email alerts at canmedevents.com. We will be sharing details about our CanMed 23 event across all our platforms very soon, so stay tuned. We are also hard at work adding video recordings of all of our CanMed 2022 oral presentations and panel discussions to the CanMed video archive, and we will be making an announcement about that soon as well. One last thing, please rate, review, and subscribe on your favorite podcast app. Doing so really helps the podcast reach more listeners. Okay, that's it from us. Stay safe, stay healthy, and please join us on the next CanMed Coffee Talk.